Welcome to the lecture series of boundary value problems. Today we are going to discuss about one-dimensional wave equation. Under this one-dimensional wave equation, we are going to consider a string. That string is stretched and fixed at both endpoints. Okay, so you consider a string. At this point, we will take it as x is equal to 0 and this endpoint. So both the points are endpoints. So the length of the string is L. Okay, so we are considering a string which is stretched at the both endpoints. This point is x is equal to 0 and this is x is equal to L. Therefore, length of the string is L. Both the points are fixed and endpoints. Therefore, the length of the string is L. So, the displacement made by any point at a distance x units. Okay, at a distance x unit. At the time duration is t. Then the displacement function denoted by y of x comma t. Okay, because the time is t and the displacement unit is x. So this displacement function satisfies the PDE. So this displacement function satisfies the PDE dou square y by dou t square equal to a square into dou square y by dou x square. We will call this as equation 1. This equation is nothing but one-dimensional wave equation. So here a square, where a square equal to tension by mass. Okay, so where a square equal to tension by mass. So equation 1 is nothing but one-dimensional wave equation. This displacement function satisfies this equation. So this equation is called it as one-dimensional wave equation. So the same equation can be written as y suffix double t equal to a square into y double x. That means what? Second derivative of y with respect to t and second derivative of y with respect to x. So this same equation can be written like this also. If suppose the displacement function instead of y of x comma t, if I am taking the displacement function as u of x comma t, okay, displacement function is, if I am taking u of x comma t, then equation 1 can be written as dou square u by dou t square equal to a square into dou square u by dou x square. So this is also the same only. Now we are going to see the boundary conditions. So under the boundary condition only we are discussing about all these things. So what are the boundary conditions? First one, y of 0 comma t. What is our displacement function? Displacement function is y of x comma t. Now I am taking the first condition as y of 0 comma t. That means what? 0 comma t means what? X is equal to 0, because x is equal to 0 is the end point of the string, isn't it? This point is fixed. So at this point the displacement made by that end is 0. That is why the first condition is y of 0 comma t equal to 0. That means what? This is x is equal to 0. X is equal to 0. It is a fixed end point. So there is no displacement. And what is the second condition? Second boundary condition is y of L comma t equal to 0. What is y of L comma t? What is that meaning? Y of x comma t means displacement function. Now I am taking y of L comma t. That means x is equal to L. What is that x is equal to L? X is equal to L is also another fixed point. Okay, fixed end point. At this point x is equal to L, there is no displacement function. So that is why y of L comma t equal to 0. So this is the second boundary condition. Now look at the third one. What is the third one? Third one is y of x comma 0 equal to 0. What is this? Y of x comma t means time is there. Now we are taking that time is 0. Time is 0 means what? Initial displacement. So that is nothing but initial displacement. Okay, so this is our third one. What about the last condition? Fourth condition is dou by dou t y of x comma 0. This is the fourth one. What is this dou by dou t y of x comma? This is nothing but differentiation of the displacement. That is nothing but what? Displacement differentiation is generally it is velocity. If we are differentiating again, that will give us acceleration. So this is nothing but initial velocity. Okay, so these are the four boundary conditions. For this boundary condition only, we are going to solve this one-dimensional wave equation. So here we can discuss about the solutions also. Solution of one-dimensional wave equation. There are, it's a very important 2-mark question under this. Say what are the possible solution of one-dimensional wave equation? There are 3 equations are there, but we will take the solution, right solution as y of x comma t is equal to c1 cos px plus c2 sin px into c3 cos pat plus c4 sin pat. We are taking this solution as the right solution of the one-dimensional wave equation. You know why? Because we are taking this one means this condition, that is this solution only satisfies the boundary conditions of the string. Okay, we have taken a string, no? So this solution only satisfies the boundary condition of the string. That is why we are taking this one as the solution of right solution for the one-dimensional wave equation. Now under this string, first type 1 problem. What is type 1 problem? We are going to see different kind of type of problems. So here the type 1 is initial velocity is 0. Initial velocity is 0 and initial displacement, okay, initial displacement given directly. Okay, so type 1 is initial velocity is 0 and initial displacement function will be given directly in this type, that is type 1 problem. So under the type 1 problem, how we are going to do the problem? First we have to write the one-dimensional wave equation and we have to write the correct solution of one-dimensional wave equation, and then the boundary conditions we have to write. Okay, so this is the way we are going to do the problem. Boundary conditions we have to write. We have to apply the each boundary condition, we will get some answer. Finally we have to apply the displacement function and we have to solve that in displacement function by the half range Fourier sine series or cosine series, whatever it is according to the question. We have to solve that, we can get the solution for the one-dimensional wave equation. So this is the basic of the string problem. So based on this only, if you are understanding these things very clearly only, we can do the problems easily. So the string, it is fixed at 2 endpoints, x is equal to 0 and x is equal to L. Length of the string is L. Okay, so the displacement function y of x comma t satisfies the one-dimensional wave equation, and therefore we are getting this equation. And here instead of y of x comma t, if you are taking the displacement function as u of x comma t, that equation can be written like this. So the boundary conditions are 4 conditions are there, and the right solution of the displacement function is y of x comma t equal to c1 cos px plus c2 sin px into c3 cos pat plus c4 sin pat. So the type 1 problem is initial velocity is 0 and the displacement function given directly. So based on this we will do the problem in the next lecture. Thank you for watching.